Thank you, Karen, and thanks everybody for joining. I'm Steve Solon. I'm one of the corporate solution architects for both XIV and the flash systems. Been working with the Spectrum Accelerate family, we'll call it that, since we acquired them back in late 2007, early 2008. Today we're talking about two separate but very closely related topics. We're talking about provisioning and snapshots. And it's hard to talk about provisioning without talking about what the management tools are. So there's a lot of different ways we can get to the box, right? I've got the Hyperscale Manager, and we'll see some screenshots of that. We have a command line interface. Spectrum Control actually does some management. It does not actually do provisioning at this point in time. The REST API, I'm able to do provisioning. This deck was built for the Accelerate family, so I'll take this line out. The XIV GUI does not work for the A9000. The mobile dashboard does. And again, the Python library is essentially, we've open sourced the CLI. So again, if there's need to be customized work done, we can actually look at the Python library and do work on the CLI. And I do have at least one customer I'm aware of that's doing that. They actually wanted to add in a reference number that they create for each volume, so it's easier for them to sort and track, and they've gone ahead and done that using the open source that we've provided. So Hyperscale Manager is probably the main tool for managing. Again, the next would be the CLI. It does support the entire Spectrum Accelerate family, so I can manage my A9000s, XIV Gen 3s. I won't manage a Gen 2, but we'll manage a Gen 3. And also Spectrum Accelerate can be managed through the same GUI. It's web-based and installed on Linux, typically on the virtual machine. The big difference from this and what I call the classic GUI, the XIV GUI, it's very easy to have parallel tasks running in this one, where it's not that easy to have parallel tasks running in the classic one. It does have links to both the REST and documents, and also if you install this, or when you install this, you actually install a special version of Spectrum Control base in the background. And again, that's for this appointment. It's for VMware integration. We have a new version out that is not yet bundled with Hyperscale Manager, the 3.2 version, and that actually also includes some PowerShell integration with for the Windows family. The requirements are there. You need to root privilege on the server to install the executable, and then again, using Firefox or Chrome, I go ahead and connect to complete the config. And you do have to have one system available to complete the config. It is a requirement. There's an actual live system out there to talk to finish configuring the Hyperscale Manager. And I can manage up to 144 systems. Here's a picture of it. Again, this picture shows at least one of each. I got 3 flash systems, 3 XIVs, and 1 Accelerate in this particular screenshot. The one thing I wanted to kind of focus on is over here in the dashboard, I've got a health widget, right, and I get a health percentage. And if you look here, I can actually come over and click that. I call it a sprocket. I'm not sure what I'm supposed to call it. And I can actually configure the percentage that I subtract for different failures. So if for some reason, let's say, running out of space is a bigger deal, right? Or here it's a -1%. I could go into that and change that to be -10%. So I can make it a bigger deal. I can configure the relative value of these things to better match the customer's interpretation or our interpretation of what's important and what isn't. Again, I think the advantage is I can manage the entire Spectrum Accelerate family. So if the customer has XIVs and A9s, I can manage everything from my one screen. It is a much broader and deeper view of the environment, especially given the dashboard at the front. and I can have multiple tabs open at the same time, so I can actually have multiple tasks going, and I can move from one tab to another very easily, and the tab remains, and it keeps the status of my work in that tab. Again, I got the command line interface as well. I can download that directly from Fix Central, or I can go into the GUI and download it through the GUI as well. And when I'm running the CLI, it is not running through Hyperscale Manager. It is talking directly to the particular machine that I set up. Mobile dashboard is available for alerts. I'm not actually doing any management. I'm just doing monitoring through the mobile dashboard. And then I talk worry about the Python library, and there's a link for those that are interested. So that's kind of the tools we can use to do provisioning. Again, most of the examples are done through the HSM or through the GUI. But there are 4 basic steps. I'm going to create a pool. I'm going to create volumes in that pool. I'm going to define a host. I'm going to map volumes to the host. Now, I can create one very large pool and manage everything just by volume name. If I choose to do that, I do have customers running that way on both A9 and XIV. Or I can create pools based on whatever sort of logical definition I want. I can do it by department. I can do it by application. I could do it by server type. There's no performance implications to having a pool or having multiple pools. Again, the A9 uses the grid architecture to spread the workload over the entire machine. So a pool is a logical boundary, not a physical boundary. I'm not limiting when I assign capacity to a pool. I am not limiting it to only a subset of the box. I'm essentially creating a logical boundary that still uses the grid architecture and still uses the perfect distribution, but I'm just, again, creating some logical separation. The other thing that can be done here, right, is I can combine a pool with multi-tenancy, and then I create a pool inside a domain, and I can, as an admin, I can be an admin of more than one domain. So it's logical then to see the domain name pop up as part of the pool definition. Again, volume size is important. System has to know where to go, which domain on that system, and then which pool in that system and or which pool in that domain. I can start and create a pool as part of this process as well. So again, it's very flexible in terms of what you can or can't do. And again, we already talked about this a little bit. Pools are logical boundaries; they're not physical boundaries. They're for capacity management. Again, thin provisioning management for XIV only. I really don't do thin provisioning in the A9000. I mean, the box does that, but unlike the XIV, where I physically manage soft capacity and hard capacity as part of a pool and as part of the box, the A9000 has virtual capacity that it manages for you, and you just create the pool and the volumes within the pool. And then, again, as part of that dashboard that I showed you, it will show you how much data has been written, the amount of data reduction that we're getting, and the amount of hard capacity that's actually been used after the data reduction has occurred. Again, no performance implications, because I'm not doing any RAID decisions, not doing volume layout decisions. I'm just saying I've got this much, in the case of A9, I've got this much virtual capacity that I want to use, so I'm going to assign some of that to this pool and use that to create volumes in the pool. I can very easily resize pools. I can make them larger. I can make them smaller. Now, I'm not going to, you can't make it smaller than the volume set that you have. But let's say I create a 10 terabyte pool and I only create 5 terabytes worth of volumes. I can very easily shrink that pool down to 5 terabytes to only use the space again, that virtual capacity that I need for the volumes. And then as we're showing here, I can set pool thresholds. I can either set them system-wide or I can set them specific for a pool. I can set them on both volume usage and snapshot usage. And then again, this is the pool full thresholds. Again, creating volume, I need the pool, the volume size, can specify in gigabytes or terabytes, the name and the system. And the benefit of the grid is it really doesn't matter how many volumes I have, I focus the resources of the grid on the active I/O. And here you see again, for the A9, A9000R, and I just typically just say A9000, and I mean both of those. I'm not saying just specifically the smaller version. Come to think that I don't think you guys are getting the A9000. I think you're only getting A9000Rs. But again, we bumped up the number of volumes from 12 in XIV to 16,000 for the A9000. We've changed the volume size, right? A min volume size and max volume size here. Now, there are some differences, right? And on XIV, because again, this is basically the same, based on the same code, but it's not the same code. In XIV, I have what I call an allocation unit of 17 gigs. So all my pools and all my volumes are created on 17 gig volumes. And that's based on a 1 megabyte partition size. Well, the A9000 has a 16 megabyte partition and 103 gigabyte allocation size. So when I create a pool, I will always create a pool on a 103 gigabyte allocation unit size. So if I type in a number, it will automatically get rounded up to the next multiple of 103 gig. Now, the minimum size for a pool is I want to say 2,000 gig, but I think I've got the number in here later. So there's the minimum size for a pool. The minimum volume size is 1 gigabyte, so much smaller, right? But the difference there is, and this is kind of strange, is I can create any volume size I want up to 95% of that 103 gigabyte allocation unit. If I get within 95%, it's going to automatically round up. So it creates some sort of strange behavior. I can create a 98 gigabyte volume on an A9000. I cannot create a 99 gigabyte volume. It's going to round up to 103. So with typical volume sizes we're seeing, right, in a couple terabytes or even more, that small amount gets really lost in the noise. But if you're creating smaller volumes, you may see an automatic roundup, and it's because of that you're close to the 103 gig allocation unit, and it's going to automatically round up. I can resize the volume. I can make it larger, essentially with no restrictions at all, as long as there's sufficient space in the pool. And if there isn't, I can resize the pool. Obviously, I'll take different actions based on what OS is seeing it to take advantage of the new space. I can decrease the volume size, but it can't be mapped to a host to decrease that. So unmap it to decrease it. And it's not going to let you decrease it smaller than the utilized space. Again, use this with extreme caution. But again, the feature is there. Because a pool is just a logical boundary, I can move a volume from one pool to the other. The only caveat there is the snapshots are associated, and we'll talk about snaps a little bit later, but the snapshots are associated with a volume. So if I move a volume to a pool, I move all of the snapshots with the volume to the new pool. So I may affect depending on how many snaps and how long they've been around and how much write activity I've had to that volume, I may be significantly affecting the snapshot reserve space in the pool when I move a volume. I can set and modify quality of service on a volume basis. I can view statistics on a volume basis, and that there are cases where I can automatically change the volume size, right? If I've done a snapshot, again, we'll talk about this in a little bit. If I've done a snapshot, made that snapshot writable, increase the size of snap, and then I restore to the volume, that restore will increase the size, will change the size of the volume. Same thing with volume copy. Same thing with synchronous mirroring. I can change the size of a master in a synchronous mirror relationship and will automatically change the size of the subordinate. I was just showing the animation showing the volume size changing and moving from pools. Again, so the provision capacity dashboard view, here I have, right, how much is written, how much is available, again, how much is written versus how much is allocated, if there's any reclaimable capacity, essentially that's unused volumes. I have my physical usage over here, showing my physical size, how much I've physically used, right, I've written 60 terabytes, I've only actually stored 27, almost 28 terabytes. So I have another 57 terabytes free in this system. The projected system capacity is analogous to effective capacity. But what they do to calculate the projected system capacity is use one of two methods and soon to be one of three methods. So the default method is to assume a data reduction ratio, and it assumes 5 to 1, so that's the default. And as I write, I know what the data reduction ratio is for data that's been written. So I do an algorithm that combines both of those. So essentially, my projected system capacity is how much I've written at that data reduction rate times how much is left times the expected data reduction rate. So it becomes important to keep an eye on this. If, again, based on data, customers getting less than 5 to 1, and I'd actually say 4 to 1 is probably more typical of the boxes in the field that call home. We're seeing about 4 to 1 now. The number started out lower, but over time it has grown. If it becomes important, let's say that we've not changed the default and it's 5 to 1 and the customer has some of their data sets are non-reducible. Let's say they're destroying images, which aren't going to compress very well. So they're only getting 3 to 1, but the box is saying it's expecting 5 to 1. So that projected system capacity is actually going to be an overly optimistic estimate of what is going on. So what you can do is, again, click on this little sprocket here. It will go and allow you to change what the expected data reduction ratio is, change that closer to what they're actually seeing, and then the projected system capacity is going to drop, but it will be a closer estimate of how much they can actually store on the box before the box gets full. And then in the 5.2 code, which I've actually I've got running, so I can probably show you this, we actually add in a different option, and the other option is don't do any sort of algorithm, just take what the data reduction rate that I currently have based on the data that's written and show me the projected system capacity against that. The reason they did it the other way is especially when I'm first adding workloads to the box, and some of it is reducible and some of it isn't, that number had a tendency to bounce back and forth a little bit, and using that algorithm kind of smoothed that out a little bit so that the numbers weren't changing as drastically. But again, my preference is to just change to show me what the projected system capacity is based on what I've actually written. And I know if I'm in a high write activity, I know if I'm adding new workload, I know that I need to wait a couple days to let that number settle out before I make any decision based on that. So again, I do a host definition. So I've created a pool, I've created a volume, the volume is ready to go. I need to assign that or map that volume to a host. So I need the name of the host, and the name doesn't matter. It's the name of an object. Most hosts are going to be default. The only two exceptions are HPUX and ZVM. And then I have to do this on a system. And then I have to find the host ports again. So there will be a pull down of logged in initiators, or I can type it in. I can use the host attach kit to find it. If I'm doing an iSCSI host, I would put in the iSCSI IQN. I can also define a cluster with both public and private mapping, and then I can add that host or cluster to a domain if I choose to. I can actually add the host or cluster to a domain. So best practice for doing this, right, is I want every host to see every grid controller in the A9000. Now, what we're showing here is I'll say it's a little bit, not a little bit, it's severely overdone, right? I typically don't need a connection from every initiator to both ports on all grid controllers. You got to be careful. A full up A9000 has 12 grid controllers. Excuse me, 6 grid elements, 12 grid controllers. Each of those have 4 ports. And again, like XIV, we use 2 for replication, 2 for host definition. But that's still a potential of 24 paths. And especially in a VMware environment, that's too much because we've got the path limitation per cluster. But I can show the connectivity. Again, it'll show the worldwide port names and which targets that initiator sees, or actually, more accurately, which target sees which initiator. Because again, this is from the A9000 perspective. But best practice would be to have at least one path from one initiator to every grid controller. And we've got I think in session 4, we'll talk a little about performance, and I'll go into zoning a little bit more in that session. So there's also a host attachment kit. It's available for download to Fix Central at no charge. Available for most platforms. We have support requests, sometimes support requests that we take use the host attach kit to run the diag from the host perspective. There are both installable and portable versions of those attach kits. If the customer doesn't want to install the host attach kit, but they're having a problem, we can download the portable version. It's basically just copy the XC, the executable, onto the host and run that executable. It would be, I think it's XIV_diag for diagnostics. It's XIV dev list to look at what devices are. There's an XIV attach. So basically what the host attach kit does is it creates an environment where, regardless of which operating system I'm using, let's say I've got all of those listed above, or I've got Windows, Linux, and AIX. I would go and I would attach the XIV, or excuse me, the A9, actually both, to the host by doing the same action, being the XIV_attach. And that command line is the same, and then the host attach kit understands the differences in the host operating system to go ahead and do that action. But I don't have to I don't have to remember a bunch of different commands based on which different OS. I just do an XIV attach, and I can talk to the A9000 or the XIV to do the attach. It also validates patches and driver versions and adjusts some system tunables. Again, what it does is it varies based on operating system, and that is detailed in the README. Currently, we're using 2.7. I've got a 12.1 code coming for the A9000. I'm going to announce that in early May and ship it in late May. We'll have to do a separate session on that. I'm bringing in HyperSwap, so an active-active solution on the A9000 with the 12.1 code, and and we'll set up a session on that in a while. Again, we got to get that into your guys' testing and get the documentation done. Once that's done, we'll go ahead and do a session on HyperSwap as well. And that will be version 2.8. It's always suggested to use the most recent version of the host attached kit, whether you're using the features in the firmware that go with it or not. So as of May, right, we will say instead of using 2.7, use 2.8. That'll be the newest version of the hack. Volume mapping, I can do it a couple different ways, but typically I select the volume map and then the view and modify mapping in the hub above it. I can default this to automatic. I can change the numbers, the one numbers later. I can actually move it where it is in the map. But it makes, again, the what we call the hub makes it very easy to see. The 9 volumes are attached to. I'm going to attach 9 volumes to a host right here because I've already got the volumes selected. I can select multiple volumes. I can do a volume at a time. Again, I support multi-tenancy, so I can be doing this in a domain, or I can elect the default is to not to have multi-tenancy. So it'd be I think it's called a global domain. We'll see that when we do the demo. But a domain is essentially a subset of the box. So I can carve the box up again logically so that a domain administrator only sees the resources that I assign as the global admin, the resources that I assigned to the domain. And again, a user can be a member of an admin of one or more than one domain, and I will assign specific resources. Right, a pool can only live in a domain, which means a volume can only live in a domain, because a volume can only live in a single pool. Again, here's some of the things I can assign to the domain as part of the multi-tenancy. Quality of service is probably more important. I can set quality of service on a domain basis, on a volume basis, on a pool basis, or on a host basis. And I can limit either IOPS or bandwidth. I can also make the quality of service class independent or shared, meaning if it's independent, each element of this quality of service gets, and what we're setting here, right, is 100 megabytes per second. If I say it's shared, then every resource in this quality of service class can collectively get 100 megabytes per second. So I have two different ways of setting the quality of service in independent or shared. And again, I can set it as low as a volume, or at a pool level, or at a host level. And if I say, let's say I've got 10 volumes, and I set each volume to do 1,000 IOPS, but I only set the host that they're associated to do 5,000 IOPS. And then I'm going to pick the most restrictive quality of service and apply that. So if I say, let's say I said, it's the same host, and then it's 5,000 set to 15,000, but I only have each volume doing 1,000. Again, I'm going to use the most restrictive. So that host will never get 15,000 IOPS. The most it can only get is 10,000 IOPS, because each volume it sees has the limit of 1,000 each. So again, the most restrictive limit, regardless of where it's applied. All right, so that's provisioning. Are there questions?
Remember, *1.
Karen, it's good to hear you. At least I know I'm still on the line.
You are good. Somebody have a question?
Steve, Ramesh here. Yeah, thank you. If the allocation unit is 103 GB, does it mean that we have to allocate volumes in the multiples of that?
No. No,
Okay.
again, it's very unusual in that they chose to restrict that only when you're at 95% of that limit. So there's again, I almost call them corner cases. Smaller volumes. So again, like I said, I can create a 98 gig volume, but it won't let me create a 99 gig volume. It'll automatically round up to 103. So it's only as you get to 95% of 103 or a multiple of 103. So it's almost unnoticeable. Again, typically I'm seeing, especially in the virtualized environment, very large volume sizes, 4 terabytes, 6 terabytes. I've got a customer running data storage at 10, 12, 14 terabytes. And once you get that big, that 95% of 103 is lost in the noise. So it typically is only when you're creating what I call smaller volumes, right? That you might see that roundup error. Just that roundup. Just to be aware of it. There's some reasons why. It has to do with how we utilize the space. And it turns out that a volume that's very close to the limit but isn't at that limit can create some very ineffective use of that space, so they chose to put that limitation in place.
Okay. Thank you so much. And I have a last question. Yeah, one more question is, could you please cover something about hyperscale manager host requirements and the hyperscale manager failover to a DR site?
Okay. Good question. So Hyperscale Manager is not required to be running for I/O to occur, right? It's a management tool. So as of this point in time, there is not a way to automatically create a failover of Hyperscale Manager. Now we were working. Somebody's working on the process. We would actually export the config and import the config at a secondary site. So then I would just log into that that other Hyperscale Manager. In the event of a disaster, I just log into the Hyperscale Manager, and it would automatically have the config from the previous one. But right now, I don't have a built-in utility or capability that allows me to have a master subordinate pair of the Hyperscale Manager.
Thank you.
But I am working with some of the strategy team to come up with a process to have a standby copy ready.
Got it. Thank you.
Any other questions?
Steve, there's another question from Keith Nelson on Ameriprise. He can't get his phone to unmute, but he's asking, can you specify SCSI IDs for the LUNs as we have run into this issue with SBCs?
Yes. Yeah, I can do that. It's easier to do that when I'm doing it one at a time, but I can do it as a block as long as so I can take a block once. I can start it at, say, I can start it at 16, and we go 16 to wherever. But yeah, I can specify where each line goes from its SCSI ID. Default is automatic. It just puts it in the next open slot, but I can change that behavior and place it where I want it to go.
Okay, I think my phone's working now, Steve. Issue that I have, we'll have a clustered system, and we've got them, and then 6 months, a year later, they'll add another server and want to share the LUNs. So how do I ensure that the SCSI IDs match up? Because I've run into problems having multiple SVCs, having duplicate SCSI IDs across all of the LUNs for the servers. And so we've started specifying SCSI IDs anytime that we map new LUNs now.
Hey, Steve, this is Dave Schustek. Just piling on to that, SBC guys with their latest code have a host group definition so that you can just add a host into a group and they all get the same presentation, you know, homogeneously across the pool. But that's for SBC, not a, good.
No, they stole that from us. We already have that.
Okay, so a year later, a new server comes along. I just add it to that host group, and it'll ensure that everybody has the same SCSI ID. Okay.
The cluster. So I mentioned that you can create a host or a cluster, and a cluster is an object that contains a number of hosts. And I would just add that host to a pre-existing cluster, and it would automatically get the exact same mapping.
Oh, okay. Thanks.
Yeah, I like to be able to tell people when SVC copies me instead of the other way around.
That's good stuff. Hey, I was going back to where you had the projected piece out there, and they're using 5-to-1. If I remember Jim's rule of thumb, it's you assume 3-to-1 until you know better. So I would suggest that people set that for 3-to-1 until they know better.
Yeah, that's easy enough to do. Let's zip through snaps, and then maybe we can actually bring up the GUI, and I can show you where to do that. So we're going to move forward now. Looking at snaps again, we're going to talk about snapshots and a bunch of things you can do with snaps. It is a differential point-in-time image. It is only uses space for the differences. The master and the snap are have to be in the same pool. The snaps are dependent on the master only, not on each other. So the benefit to that is I can manipulate snaps however I want. I can create snaps, I can delete snaps, I can restore from any snap to a master in any order. When I do a restore, I don't prune the tree. So I don't limit my options for future restores if I restore from the wrong snap, like it happens on some other technology. And again, I don't use space for the snap at time of creation. I only use space as I write to the volume. Essentially, and you see the picture at the bottom, right? The volume here, and I've got the snap, which is just a copy of pointers to the same partitions. So a snap happens very rapidly because really all I'm doing is copying pointers and saying, hey, here's my snap. And then as time goes by, right, and I update the master, I essentially change the definition of the master, of the volume, to be a different partition. So again, redirect on write instead of copy on write. So eventually just write that data to a new partition, change the volume definition to include that partition instead of the old partition, and then what you see there is the difference then is the snap is only pointing to the purple blocks where the volume now is pointing to some purple and some yellow. So again, the snap has that picture of that point in time, the volume continues to move forward with new data. And again, here we come up with that allocation unit again. Again, 17 gig on the XIV, 103 on the A9000. So I will as I need space, I will grab it in allocation units. Then I will fill it up with certain caveats. But I will fill that at that allocation unit up, and then grab another one. So you'll see larger jumps. Right, on XIV, we're used to seeing 17 gig jumps in both the snap space and the volume and the snap space use. All right, can you hear me now? Yeah, I got muted. All the time.
Oh, okay.
So I unmuted myself, so I'm back. So again, multiple snaps can share the same allocation unit, but what I can't have is I can't have the same offset into a volume sharing the same allocation unit. So, and that's why we have them offset a little bit again on the earlier in the XIV, they were lined up. It was an exact, it was 16384. We moved that to a prime number, 16583 or something on the A9 at 6161. So again, I've got an offset to avoid, because it's very common, right? If I've got a volume with an index on it, that index is always getting updated. And that would cause a separate allocation unit to be caused for every index. But now that I've got them offset, I can use other pieces of the allocation unit for the index of different volumes because they don't line up exactly over each other. So it's a detail, but it's done to maximize the amount of space I can use in my snapshot space with multiple volumes doing the same or similar actions. Again, then if I change those partitions, again, I write to those new partitions, there's no action taken at all from a snap perspective. It's just done from the volume perspective. And the reason I say that is there is some overhead. Let me go back one. There is some overhead because what I do is, again, this is going to be a 16 megabyte partition. Right, and it's very unusual to get a 16 megabyte write. So let's say I'm going to 8K write or a 32K write. I'm going to write that information to that new partition in the right place. But what I have to do in the background then is I have to migrate the rest of that partition. I have to coalesce the new information with the rest of the 16 meg. Again, 1 meg in the XIV case, 16 meg in the A9000 case. So that creates some background work on the machine to do that coalescing. So that's where we really get the performance limit on snaps, is how much of that background work do the grid controllers have to do to coalesce what was written and the old information. But I will always, again, I'll keep that partition around, even if I delete the snap at that point in time. Before I finish that coalescing, I will keep that partition because I know the volume is still referencing. And as soon as the coalescing is done, I remove the reference from the volume to that partition, and then when the snap gets deleted, I can let that partition go. And that becomes another point. I can delete snaps independently, but based on how much write activity has occurred, I may or may not get a lot of space back when I delete that snap, because if it's only holding one partition that's different, again, not a lot of write activity occurred during the period of that snap, I don't get a lot back when I delete that snap. So again, you can delete a lot of snaps and not get a lot of space back based on duration of the time between the snaps and how much write activity has occurred in that interval. So I can restore a master from a snapshot, and then really that's the opposite. That's just taking the pointers and re-copying the pointers back. Now, the box will let you do this nearly instantaneously. There are implications higher up the stack. If this is part of a volume group, actually I will talk about consistency groups in a little bit, but what I'm doing is I can be completely changing the contents of a volume nearly instantaneously. And the box will let you do that. But again, if you're doing that, say, a Windows host, you can expect a blue screen. If you're doing that to a host that supports volume groups, you can expect errors with that volume group. So again, there are steps to take higher up the I/O stack to make sure that doesn't happen. So be very careful. The box will let you do a restore immediately, but be aware of what the implications are further up the stack. And again, I don't prune the tree because the snaps are all independent of each other. So if I've got 4 snaps, and let's say I got a database that got corrupted and I want to restore it, and I restore the wrong one, it doesn't matter. I just go to the next snap, then the next one in time, and do a restore. I don't have to worry about, am I going to lose flexibility in restoring if I restore from the wrong snap. Again, that just shows the animation there of the volume changing. I can update a snap. I mean, I can take a snap. I can unlock it. Again, they are read-only by default. I can unlock them, make them read-write. I can write to the snap, and then I can also restore from that snap to the master. So I can change a little bit of information and then do a restore. I can change the size of the snap and then do restore. So again, be very careful doing restores because the box has a lot of flexibility in what it will let you do. But if I decrease the size of that snap, and I can do that, and then do a restore, I'm going to automatically decrease the size of the. Actually, I can't do that because if it's mapped, I won't let you automatically decrease. But if I increase the size of the snap and do a restore, I will automatically, instantaneously increase the size of that volume. Again, most operating systems handle volumes getting larger, but you need to be aware of implications to the application, to the file system when you're doing a restore, because the box doesn't really know or care what's going to happen further upstream. I can overwrite a snapshot, meaning I can change the contents of a snapshot, excuse me, without changing any of its identifying information. And this is useful in the backup restore, and I'm going to talk a little bit later about formatting snapshots, and we'll talk more about overwrite and format in that instance. But again, I overwrite, I instantly change the information of the snapshot without changing its identifying information. And the animation of all that. I can create multiple snaps, right? Again, this is just showing the picture of the pointers of the multiple snaps. I can create a snap of a snap if I choose. So again, this can be useful in a test environment where I've got a copy of data that's interesting and I want to run 14 different tests on it at the same time. I can make 14 copies of it, have 14 hosts, and run those tests in parallel. I can even I have been using this deck for a very long time, and I just realized up in the title here, it's restore a snapshot from a snapshot, not a snapshot. I don't know how long that typo has been there. Anyway, sorry about that. I can restore a snap from another snap. Again, no restriction, as often and in any order that I want. I have the ability to format a snap. So that essentially says, again, take all the information out of the snapshot, but keep its identifying information. And this is, again, useful in a backup situation. And what it does is it helps free up compute resources as well as snapshot space. But remember, once I take a snap, I am constantly doing this redirect on write and coalescing what's in the rest of the partition with what was written. So let's say I take a snap of a volume to do a backup. Take the snap at 2 o'clock in the morning, start the backup process. By 4 o'clock in the morning, my backup is done. I've already taken that information that I need and I've moved it to another media, tape or you know, a cheaper disk, you know, moved it to the cloud, whatever I've done, I have that information hardened. I don't need it anymore. So I would then go ahead and format that snapshot. Now the nice thing is the format doesn't change the identification properties. So the next day at 2 o'clock, at 2 a.m., I overwrite the existing snap. That snap is already mapped to my backup server. So I do an overwrite, do my backup, do my format. So what that does is that ensures that I'm not using resources to, again, keep the information and to coalesce from the redirect on writes during the course of the day when I really don't need to. Once I'm done with my backup, that information is done. I don't need it anymore, so I go do my format and then right before I need to do my next backup, I do an overwrite, and then just loop. And again, it just shows I'm removing the partitions from the snap, but I'm not changing the snap itself. I do have consistency groups for snapshots, so I can put multiple volumes in the consistency group and take a snapshot of the consistency group, which will give me a picture, a point-in-time copy of all of those volumes at the same point in time with respect to each other. So any action I can take on a snap, I can also take on a consistency group. All right, and I take so I have a snapshot group. I can also, even if I have a volume in a consistency group, I can still take a snap against that volume by itself, or I can take a snap of the consistency group. Right? If I disband the consistency group, I just disband the relationship between the snapshots. I don't delete the snaps. They stay, and they are still only dependent on the master. So the A9 does automatic deletion of snapshots. And again, this deck came from a combined session. So I left it here because it's important. Even though I do not have a golden snapshot yet on the A9000, I still have 4 different priorities for my snaps. So again, 4 is first, 1 is last. And again, I'll go to a backup for this. I'm doing a weekly, a daily, a weekly, and a monthly. So I have 3 levels of snaps. I'm going to do my dailies as priority 4. I'm going to do my weeklies as priority 3. I'm going to do my monthly as priority 1. So what that says is, as I'm taking the next snapshot, if I need space, I will delete the oldest daily first. Excuse me, the oldest hourly first. I'll go through and delete all the hourlies, and then I'll start back with the oldest daily. I'll delete all the dailies from the oldest to the newest, and then I'll get to the last one, which is my monthlies, and I will delete my monthly from the oldest to the newest. So it helps the box. Excuse me for a second. Sorry about that. It helps the box understand which snaps are most important to us. And then just some scenarios, right? Again, for the most part, volume size is okay. But again, from an operating system perspective, they're okay, but there may be application implications of increasing the volume size. So let's say I don't know how it's exactly going to work, but I want to test it. So I have my master volume running production data. I take a snapshot of that master volume. I make it writable. I create a new instance of the application, map it to that writable volume. Then I go ahead and start the application and resize the snapshot and make sure that the application can deal with it, right? Both the operating system, the file system, and the application can deal with it. And if it doesn't, I haven't broken production. I go back, I figure out what went wrong, I restart the process, I can do it iteratively until I get it right. And then once I have the process down, then I know I can go into and resize my master volume in production and not affect production. We talked about this a little bit, right? If I'm doing testing, I may have certain builds that have certain characteristics, or certain data has certain characteristics, and I want to make multiple copies of those so I can run multiple tests at the same time. Now, the other thing that's related is the volume copy. So again, we've talked about snapshots. I do have the ability to take a volume copy and take a volume copy of either a volume or a snapshot and make it a volume. So on the A9, this is the only way I have to know that I'm not going to automatically delete a snap. Is if I find a snapshot that's very important, probably want to go ahead and do a volume copy and make it a volume, because the volumes are never automatically deleted. Snapshots are. Now again, future I should have that deletion priority 0 or golden snapshot for the A9, but I don't have it as of yet. So again, to a source, to a volume, I can make it either from a snap or from a volume. And again, I create a new volume potentially in a different pool. Here are some of the differences between the volume copy. Basically, no space for the snap, full space for the target. Target is independent. It's never deleted. Lack of space to talk about that. It's a background copy from the source of the target, and I can copy they can be different pools where the master and the snap have to be in the same pools. And I'm hustling because I just looked at the clock and I'm about out of time, so I wanted to I'll leave the summary there. Are there any last minute questions? I don't have a hard stop, but I know some of you guys might. So any questions about provisioning or snapshots? All right, so what I'm going to try to do with the last remaining minute that I have is go back to the GUI and look real quick.
Hi, Steve, Atul here. Hi, Steve, Atul here. Before a couple of slides back in the snapshot, we see that the space increment size is 17 GB in XIV and 103 for A9000. So can you please elaborate more on that part? What is that for?
That's basically when I grab space, I grab it in allocation units. So I will then use 16 megabyte partitions inside that 103 gigabyte allocation unit until one of two things. Either that 103 is all used up, or until I find a snap that, due to its index, would land in the same partition. I have to go get another allocation unit to get a partition that doesn't line up on the same index. So basically, it's just an internal way for the A9 to manage space. And the reason I put the sizes up there is I think we're kind of used to space going away in 17 gig increments on the XIV as it grabs allocation units, but it's going to go away in 103 gig increments on the A9 because that's the size of the allocation unit it grabs. It doesn't really have any real effect on the at the end. It's just a little bit different. I wanted to highlight the difference.
Okay, Steve. Thanks. It's clear now.
So here is what I was talking about with the estimation. This is 5.2, so this is a little bit different, right? So this is showing a combination of my estimation and the system actual, or right, and my preference is just do this and show it based on system actual. But it gives you the opportunity then to change that projected allocation. And like someone was saying, if you want to use estimation, right, come in here, and it's better to set it low and then bump it up over time, because that basically what that does is that says I'm going to be able to use more space. The danger is if it's too high, that we'll run out of space before that we've estimated we're going to run out of space because my estimate number is too high. Just want to show that real quick. That's how you go in and change that. And maybe I should talk to the strategy team, and we should come up with a best practice around that. So that's done all the time.
Yeah,
I think
Steve, this is Dave. I totally agree. That ought to be part of the best practice to start out with a setting like that. That, I believe, is Jim Molson's, thumb in the air until you know more right now.
Yeah, again, it's always better to guess low. It's always better to under promise and over deliver, because it's easy to use the space that frees up. It's much more difficult to over promise and under deliver, because then you run out of capacity before you think you're going to.
Thank you.
Any other questions? All right, Karen, I'll let you wrap it up.
Perfect. Thank you again, Steve, for this informative session. I hope you all join us again on Monday, 11 Eastern, I believe it is. And if you don't have the invite, just shoot me an email. Thanks, everyone.
Talk to y'all later.